alaikum, people. Salam alaikum. Salam alaikum. Today I introduce not by saying hi everyone, but I say Salam alaikum. Ana Musulman. Ana Musulman. Salam alaikum. So today we are going to do the second section for chapter 2 for quantum mechanics. The first chapter, like the first on the previous lecture, we focused mostly on the um, you know we were aiming on focusing on the finding the time independent Schrodinger wave equation, and then we did a little bit of probability density. Then we found out the equation for time, and then we found out, all right, we found the equation for time, but fuck, finding the equation for time has no value, and so we have to actually push on to space. So we need to find the equation for space. So chapter 2, section 2, we are going to focus on what we call infinite square well. And so the potential, so if you look at the book, I'm sure you have the book. The only reason I'm not opening the book is because you get to see the iPad itself. So on the book, we're going to have the system will define as, so the system defines, 2.2. So the system defines as what? V of x is equal to 0, less than or equal to x, less than or equal to a, and infinite otherwise. If I were to draw the wall, I'm going to have this. So 0, a, there is potential inside the wall. There is no, the potential inside the wall is 0. The potential outside the wall is infinite. Correct? The potential inside the wall is 0. The potential outside the wall is infinite. So which means my psi of x here is infinite. My psi of x here are 0 respectively. Now this is what you call a piecewise function, and you have done piecewise function during your ordinary differential equation and your partial differential equations. So if you are, first of all, if you're doing this lecture, make sure that this is for people who have already done ordinary differential equations and partial differential equations. I'll try my best to do it because at the same time I also have other things occupied. So at the moment, the only course that I can really do is quantum mechanics, sadly. So there you go. Psi of x is infinite, psi of x is 0 otherwise. And the wave function rule, our wave function rule states that psi of x whole square is the probability density, and we have done this. And the only reason we square it is because if we don't square it, you get the probability, but this is what I will call it psi of x being what you call fake probability. And the only reason it is a fake probability is because not only you get a probability as a probability, but you get a probability as a negative value. And you can never have probability as a negative value. And you know very well that if you have probability as a negative value, yep, not possible. You can only have greater than or greater than 0, and the normalization must equal 1. And when you do the calculations to finding the probability of a quantum particle in quantum mechanics, you are bound, like in most cases, you are going to have a negative value. You are, especially when you do the amplitude, you are going to get a negative value. Like in some cases, you will have amplitude as negative. And so when you square it, you must square it. Only then you are able to say, okay, this is a probabilistic particle, right? So eventually, if I were to express that, this potential piecewise function in respect to psi of x, then I'm going to have psi of x being 0, 0 for x less than 0, unknown for 0 less than or equal to x less than or equal to a. The only reason it is unknown is because inside So in quantum mechanics, what happens is particle behaves both as particles and as waves. And so that is important to consider that given that it behaves both as particles and as not whales, walls, not walls, sorry, waves. So it can move like that. But to move like that, you would have to find the